Hey, Alex from GMAT Ninja here. Welcome to another one of our GMAT Focus Edition videos on data insights. This one's going to talk about key quant skills for graphical interpretation. So the first thing to say about that is the quant skills you need for graphical interpretation often aren't hugely complex or involved. In fact, a lot of it you've probably already studied getting ready for the problem solving section. That being said, there's some topics that it's worthwhile stressing and really getting a handle on for graphical interpretation. So the first one of those would be knowing when to calculate versus when to estimate. There's a lot of graphical interpretation questions where you could take some really involved and lengthy path, but that's going to kill your time, not be an efficient path. In those cases, what you want to do is, can I eyeball and estimate the data, get there in a much more efficient way? On the other hand, there's some questions where estimating could be risky, lead you to a wrong answer. So in those cases, you're going to want to actually go into the weeds and calculate a number. So the goal is recognize the difference between those two situations. We're also going to talk about correlation. Basically boils down to, can you recognize a trend in the data, knowing what positive versus negative correlation is? We'll talk about rates of change, which is all about, okay, if I have sort of a complex graph, can I understand, well, what does an average rate of change mean on this graph? What does it mean for a rate of change itself to increase or decrease or stay the same? And lastly, again, although the quant topics aren't necessarily going to be hugely complex and involved, you will get a challenging question now and then that requires, say, some intricate and involved algebra. So we're going to do an example of that with a percent change question. Okay, so in one word on that, I'm going to do a refresher on percent change and calculating percents, but I'm not going to go into huge detail. So if that question seems especially challenging and you have trouble following it, feel free to check out our series of quant videos. There's one there that's entirely dedicated to percents and goes into a lot of detail. And if you're comfortable with that, then you should be able to come back and check out this question. All right. So another thought for graphical interpretation is, well, a habit you want to inculcate is before you dive into the question itself, take some time to scan the graph, scan the text that goes along with it. You don't want to obsess over every detail. There's a fair chance that there's going to be information there that you won't end up needing. At the same time, you want to understand the big picture. What's the information that's being presented to me in the graph? What's the meaning of each of the axes? So for that reason, for each of these questions, I'm going to flash the graph and the text on the screen for 30 seconds. You can take a look at it, and then we'll check in on it before going into the questions themselves. All right, great. So we're going to take a look at 5 questions total. I've got one of each except for a correlation. We'll do 2 of those. And all right, so let's take a look at the first question. It's going to be on calculating versus estimating. Again, I'm going to flash the graph onto the screen. You can take a look at it for 30 seconds. We'll check in on it, and then we'll go into the questions themselves. All right, so let's take a look at that first graph. All right, so now that you've had a chance to scan this graph and digest what's going on there, let's see, what are the points you want to take away? Well, it's about a group of students. They've been broken up into 3 sections, so I'll note A, B, and C. That is what corresponds to the different dots, blue, black, and white on the graph. I also see the axes. That's the main takeaway I want to get. Well, it's the number of hours people studied versus the points they earned. And if I think about it, it makes sense that those two are connected. You might think, well, if you put in more hours, maybe you'll earn more points. That seems to be borne out by the graph. What else do I want to take away? Well, they give me this complicated formula for how they calculated the grades based on their points. And they give me, the number of students per section. Obviously, I don't need to obsess over or memorize that stuff. I've got the big picture. I'm in good shape for the questions now. So let's do just that. I'll put the questions on the screen, give you about 90 seconds to go through those. If you need more time, that's fine. Otherwise, let's check in once you've answered those questions. All right, let's take a look at these two questions, and keep in mind we're thinking about when do we want to eyeball, when do we want to actually go in and calculate. Okay, so for the first question, the median reported time spent studying for all students in the course was blank hours per week. Okay, now keep in mind this is a multiple choice question. There's a drop down menu, so I'll look at my options. I see those. Now I'm going to go back to the info. I have 33 students. Okay, so the median student should be the 17th. Um, and I know that there'll be 16 below, 16 above. So notice the answer should be an integer, right? If there was an even number of students, well, maybe if it was between, say, 3 and 4 hours, it would be 3.5. But because it's an odd number of students, the answer has to be an integer. So, right off the bat, B and D are gone. So the question is it 2 or 3 hours? Which one of those is the median? Which of those, if I counted up the students, would be the 17th? Well, it's kind of too close to call for my taste here. Um, I think it's probably 3 hours, but maybe it's two. I don't, I'm not that good at eyeballing to confirm that. So now let me think about, well, to count up from the lowest student to the 17th student, not a huge time investment. It's probably worth my time to do that so I can be 100% certain I got this question. Okay, so I'm not going to go the eyeballing route on this one. I'm going to delve into the details because it's not going to cost me too much time. I'll be certain. Okay, so I count up how many students studied for 1 hour, how many studied for 2. Okay, and then I end up the 17th student is the third one up the way I counted it for 3 hours. Okay, so it's going to be 3, as I suspected, but I'm glad that I actually went ahead and counted it. I can imagine something that looks like this, but, the judgment call between 2 and 3 is kind of tough. Maybe I was wrong. Okay, so let's look at the second question. Section blank had the smallest average, i.e. arithmetic mean, reported time spent studying per week. Okay, so which of these sections had the smallest average study time? How am I going to approach this one? Well, think about adding up all 11 members of each section. Those are ugly big numbers, dividing by 11. That's a lot of work. I'm tempted to say I think I can eyeball this one. So let's give that a shot. Okay, well, section A, notice they're pretty far flung. They have a lot of students studying 5 hours, 7 hours, 8 hours a week. Well, maybe not 7, but 8 hours a week. And not a huge amount on the lower end. So I'm tempted to say, nah, it's not going to be section A. Now I've just got to compare section B and C. And I notice, well, the blue section, section B, has some cluster around 4 hours. And as I go down, it looks like for each of those hours, there's more blacks than blues. Okay, so I decided calculations are going to be really time consuming. But eyeballing it isn't too bad. It's fairly clear to me that section C is going to have the lowest average study time per week. They're clustered towards the lower end. So I'm going to go with C for this one too, and that's the correct answer. Okay, so notice there's no one-size-fits-all rule. Should you eyeball, should you calculate? It's really case by case. Ask yourself, is this something that I can reasonably do given the amount of time I have per question? And is it something that eyeballing might lead me astray? So, I'd really better do something that gets into the details a bit more. All right, great. Let's take a look at the next question. And this time I'm going to give you, again, 30 seconds to scan it, make sense of the axes, read the text. Once you've done that, we'll check in on it, and then we'll go into the actual questions themselves. All right. So for this graph, there's a fair amount of text here, but notice it's a fairly simple setup, right? I have a group of 40 children, half were male, half were female. They're clustered into different age groups between 9 and 10, 11 and 12, and so on. And then I have the average compression that each of those children was able to achieve for this CPR course. And the age versus the compression they were able to achieve is graphed. It makes sense that those two are related. And that's pretty much it. I get some more details in there, but I'm not going to obsess over those. I think I'm in good shape for this one. So let's take a look at the question. I'll give you a minute for this one, and then we'll check in. All right, so this question asks, in the study, age and average compression depth are positively correlated for. Okay, so what is correlation? What do you need to know about correlation for this test? So, the definition of correlation is the extent to which two variables are linearly related. So, to give an example, let's say that we have two different variables. On the one hand, the amount of time that people spent studying for a test. I collected some data for a bunch of different people, and the score they got on the test. Okay, so if I connected those data points and they gave me, say, that line, then I could say, okay, well, those two variables are absolutely linearly related. That's perfect correlation right there. On top of that, that's positive correlation. In other words, as one variable gets bigger, the other variable also gets bigger. So not just correlated, but positively correlated. Now, that's perfect correlation. On this test, the points don't need to be forming a perfect line for you to say that there's correlation, to say that one variable is relating to another. I could have points scattered all around, and that's more likely what you're going to see on this test. And notice I've got some outliers here. But the way I've drawn it, you can kind of see, sure there's outliers, but on average the points have a higher value over here than the average value over here. So I could say, yeah, time spent studying and score on the test, that's positively correlated. Okay, so there's another type of correlation which is negative correlation, and maybe not surprisingly, that's if one of the variables increases, the other one decreases. If that's the case, then you have negative correlation. So make up some other variables, maybe the number of shots of vodka that someone took, which I wouldn't recommend before a test, but nonetheless that's what we're measuring, and the score that people got. And again, if I connected the points and they all fit on a line like this, I would say, okay, those are perfectly correlated. More specifically, they're negatively correlated. As the number of shots of vodka people did went up, their score on the test went down, which kind of makes sense. Now again, you're more likely to see on this test points scattered all over the place, right? And you're asked to make the judgment, based on this scatter plot. Are these 2 points, are these variables correlated? Is it positive or negative? And again, it's pretty messy. Not all these points, fit on a line. But we can say on average, you have a higher score with fewer shots of vodka, more shots of vodka. Well, sure, some people are pretty, had plenty of shots they've thrown back, but they're still getting a great score. But on average, the scores are going down. So I could say, okay, those two variables are negatively correlated. Now, the other option is, well, maybe just the variables are not correlated at all. So to make up an example like that, maybe I'll say people's height in inches and their score on the exam. And I would guess that if we collected data on that, we'd find just no trend whatsoever. On average at the beginning with low heights, the score on average later on, it's not going up or going down. So I'd say there's just simply no correlation between those two variables. So notice with correlation, there's nothing to calculate. You're not, getting too in the weeds. It's really just take a step back, don't overthink it. If there's a trend, even if it's not an extremely neat trend, but you notice, yeah, on average there's a relation between these variables, then you can say there's some kind of correlation, positive or negative. Okay, so let's apply that to this question. They want to know, in this study, the average age compression depth is positively correlated for. Okay, so if I look at the data points, I notice, well, sure, not every point fits neatly on the same line. Nonetheless, for both males and females, when the ages are younger, on average the compression depth is smaller, and it increases as the age goes up. So notice, fairly simple question. The answer to this one is both male and female. It's A. So that's the correct answer for this question. And yeah, if this strikes you as simple, that's a good thing to keep in mind. When it comes to finding correlations, there's nothing fancy to do. Don't overthink it. You're just trying to see, is there some kind of observable trend here? And one of the themes of these videos is, yeah, ultimately the quant, for the most part, that they're asking you to do isn't all that complicated. The difficulties, if there are any, with these graphical interpretation questions come with interpreting the graph itself, dealing with the quantity of information you're going to be given. So in that spirit, let's take a look at one more of these correlation questions. I'll give you 30 seconds to scan the graph, make sense of it, we'll check in, then you can take a look at the questions. All right, so let's do just that. All right, so what do I want to take away from the text in the graph here? Well, there was a test audience that was shown some movies, and then there's some data that was recorded. So there's the percent of comedy that was in these movies that they were shown, these previews. There's the percent of the audience that found them funny, and that takes care of my x-axis and my y-axis. And I could see how, yeah, those could be related. The amount of comedy could relate to the percent of people who found something funny. They also introduced the variable L, which is not technically on an axis, like an x-axis or y-axis, but it's represented by the size of the dots. And the bigger the dot, the bigger the value of L, which means, a bigger dot, you're more likely to go see a movie. Okay, cool. I think I've got my head wrapped around this graph and this text, so let's take a look at the question. Okay, so let's look at this question. Let D equal the percent of drama in each preview. Okay, so they're introducing a new variable, which is D. Okay, what else they tell me? Assuming each movie is made up entirely of comedy and drama, such that C plus D is equal to 100. Okay, so I'm going to think about that for a second. If C plus D has to be equal to 100, then that tells me, well, as C goes up, D goes down. So in other words, if C is like 100, if it's 100% comedy, then it's 0% drama. So that's D. And then if it's 0% comedy, it's 100% drama. Okay, so what does that mean? Well, C's going up from left to right, but D is going up from right to left, because the smallest D values would be over on the right, and the biggest D value, 100% drama, would be on the left. Okay, so I've got my mind wrapped around what does D mean in this context, how does it relate to the graph? So then the question is, there is blank correlation between D and F. Okay, so I want to see correlation. What happens as D goes up? Does F also go up? Does F go down? Or is there no relation? Okay, so as long as I'm anchored in the meaning of these variables and I kind of methodically translate what do they mean by D and how does it relate to the graph, I can see, yeah, there's a trend. As D is going up, F is going down. If that's the case, I've got a negative correlation. Okay, so notice once again, the actual concepts surrounding correlation, fairly straightforward. As long as I'm good with the basic definitions, I'm going to be okay. The complications come with how the graph is presented, dealing with all that information, being really clear on, okay, how does D relate to what's going on in the graph here? If I do that, I'm in good shape. All right, great. So let's move on to our next topic, which is rates of change and how they relate to graphs. So again, I'll give you a graph, take a look at it for 30 seconds, and we'll check in on it. All right, so what do I want to take away from this text and this graph? Okay, so I've got this scenario where there's a business and they sell fish for profit and they sell apples for profit, and they have a fish pond that's going to have waste to fertilize the apples, and the apples are going to have waste that they feed to the fish, and so they're going to help each other out. Okay, I got the big picture. I don't need to obsess over every detail there. What do I want to take away from the graph? Well, notice there's two different y-axes. That's something that I really want to stay alert to the whole time. Maybe it's just me, but my eye is always drawn to the leftmost y-axis. Typical graphs, that's where you're looking. So the fact that there's a y-axis on the right too, I want to make sure I know, okay, great, that's dollars per 10 kilograms of apples sold. So that's going to relate to the blue graph. Fish sold, okay, that's the dotted line. That's related to the leftmost axis. I know at some point I'm going to be drawn to look at the wrong axis, so I really want to stay on top of that. Okay, the x-axis is years over which these quantities are changing. All right, great. So I'm alert to a potential source of errors. I'm clear on the meaning of the axes, so I'm in good shape now. Let's take a look at the two questions. I'll give you 2 minutes for these, and then we'll check in on those. All right, so let's take a look at the first question. The average amount by which the cost of fertilizer per 10 kilograms of apples sold decreased from year 1 to year 5 is, to the nearest power of 10, nearest to blank dollars per 10 kilograms of apples per year. Okay, so there's a lot going on in that question. So let's break it down. They're asking for the average amount by which the cost of fertilizer, blah, 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 from year 1 to year 5 decreased, essentially. Okay, so which variable am I concerned about here? Well, the cost of fertilizer. Okay, so let me be careful to make sure I'm looking at the right data, the right line on the graph. Cost of fertilizer, that's the blue line, and that relates to the rightmost axis, and that looks, something like this. Okay, so I want to find the average amount by which this decreased from year 1 to year 5. Okay, so what do they mean by average amount of decrease? Well, when I read average, maybe my mind goes to the idea of arithmetic mean, and you sum up all the numbers in a set and divide by the total number of numbers, and you get the mean. But average rate of change, average increase, and average decrease on a graph, something totally different. It's actually just the slope. So I'll say that again. The average change, an average change could be average increase, it could be average decrease, but average change is just the slope between 2 points. So how would that relate to this question? Well, I want to find the average change of the blue line from years 1 to year 5. I want to find the slope from year 1 to year 5. Now notice, I don't want to overcomplicate it. There's a slope from year 1 to year 2, a slope from year 2 to year 3. So there's a bunch of different slopes, but average slope, again, doesn't require you to find the mean of anything. Average change, average decrease or increase, is just the average slope between 2 points. In this case, it's the average slope between the point at year 1 and the point at year 5. Okay, great. So now that I'm solid on that, I can go ahead and calculate it. Now I notice it said, to the nearest power of 10. If I go to the drop-down menu, scan the answer choices, I see they vary by, powers of 10, so I don't need to be super exact here. Okay, so I'm going to keep that in mind as I do these calculations. So what's the slope? Well, y2 minus y1 is 0.005 minus 0.05, so that gives negative 0.045. Okay, that's change in y. Change in x is 5 minus 1, so it's 4. Okay, I don't need to be super exact with my answers here, so to make my life easier, I'm going to say that this is 0.045 is about, just 0.04. If I divide those out, I get negative 0.01. Okay, the negative slope just means that it's a decrease, but they used the word decrease, so I could say the decrease was 0.01. So that's the answer I'm looking for. Do I find that? Yep, I scan the drop-down menu, so the answer for question 1 is E. Okay, great. Let's take a look at question number 2. After year 3, the rate of growth and the total number of fish sold per year was... Okay, and I'll scan my drop-down menu. The options are increasing, decreasing, or constant. Okay, so let's take a moment to think about what do they mean by rate of growth? What is a rate exactly? And then what would it mean for a rate to be increasing, or for a rate to be decreasing, or for a rate to be constant? Okay, so a rate is just a change in one variable, I'll just say maybe y, over the change in another variable. Let's just say x. Okay, so that's really all a rate is, and kind of like on the last question, if we're thinking graphically, well, a rate is kind of a slope, right? If I find the change in y over change in x, that just gives me the slope. Okay, so when they're talking about the rate of growth in the total number of fish sold, they're talking about the slope in the total number of fish sold per year, right? Fish sold per year is y per x in this case. Okay, so now what would it mean for a rate to be constant, or for a rate to be increasing, or for a rate to be decreasing? Well, remember, rate is just slope. So let's say over a certain period, I don't know, let's just say from 0 to 3, what would a constant slope look like? Well, just the slope is the same the whole time. That would be a constant rate of y versus x. On the other hand, what would it look like for a slope to be increasing, right? Well, maybe I have a not so steep slope, right? That's kind of a small slope. And then I have a bigger slope that follows. Okay, so I would say, well, the slope starts low, it's like a pretty small slope, and then I get a steep slope, a bigger slope. So I would say, okay, the slopes are increasing. the rate of y versus x is increasing over that whole interval right there. Okay, so keeping that in mind, okay, when they talk about the rate of growth in the number of fish per year, they're talking about the slope of, and which of the lines? Well, it's fish sold, so it's the dotted black line. Okay, and they want to know after year 3, was the rate, or was the slope, in other words, constant, increasing, or decreasing? Okay, well, I notice from year 3 to year 4, looks like a constant slope there. Okay. But then from what happens from year 4 to year 5, notice it gets less steep, right? Kind of steep slope, less steep slope. Okay, so the slopes are decreasing. I'm starting with a kind of bigger slope, and then I get a smaller slope from 4 to 5. Well, if the slopes are decreasing, that means the rate is decreasing, because rate and slope mean the same thing here. Okay, great. So after year 3, the rate of growth in the total number of fish sold per year was decreasing. So the answer to the second question would be B. Okay, so what do we want to take away from this question? Well, I don't want to overcomplicate the idea of average change, average increase or decrease, or, the rate of y versus x. Ultimately, on a graph, that's just talking about slope. If it's average slope over a certain period, it's the slope between 2 points, right? In this case, the slope between year 1 and year 5, all we cared about was year 1 and year 5. In contrast, in the second question, they wanted to know, well, not what's the average rate, but what happens to the rate in general after year 3. Well, we could say, well, now we need to look at each piece. From year 3 to year 4, we had a pretty fast rate. From year 4 to year 5, we had a lower rate. So the rate of increase, or let me put that again, the rate of growth was decreasing. And again, that led us to answer choice B. Okay, great. So let's wrap up with a challenging percent question. Same procedure, I'll give you the graph for 30 seconds, take a look at it, we'll check in, and then we'll go from there. All right, great. Let's take a look at this graph. All right. So what do I want to take away from this graph and the text beneath it? Well, I'm not getting a ton from the text. This is transactions, non-cash transactions in country C. Okay, so all other transactions by definition were made in cash, and I have different categories of non-cash transactions grouped into 2 different years. Okay, so if I'm looking at the graph, I want to be clear on the axes. Okay, so I've got the 2 different years. I've got to keep track of these different types of transactions which have different colors, etc. And then y-axis is number of transactions for each of these categories. Okay, so I just want to be clear on that. There's a lot of different ways you could measure the transactions. You could say, percents, or you could say the value of the transactions. But this is specifically just telling me the number of transactions. So something that's probably important to keep in mind. All right, great. Let's take a look at the 2 questions. I'll give you 2 minutes for this one, and then we'll check in on it. All right, so just a quick warning before we dive into these questions. Some of these are going to involve some subtle percent calculations. So I'm going to do a quick refresher on those topics, but if that kind of leaves you in the dust and you're not sure what's going on with those calculations, feel free to check out our specifically dedicated quant video, which deals with percents. That should fill in the holes there. And then if that's all making sense, you can come back and check out this question again. All right, great. So let's start with question number 1. The number of blank transactions increased by 25% from 2006 to 2009. Okay, so I'm noticing it's talking about the number of transactions, so that's exactly what's on the y-axis there. So I can look at the values and see which of these from 2006 to 2009 shows a 25% increase. Now I'm noticing, in fact, all of these categories seem to be going down, all of them except for one, which is paper checks. So by definition, the only one that could be increasing by 25% is paper checks, which is why B is the right answer to this one. And that's just a reminder, eyeballing is a good skill to have. There's a lot of questions where you don't need to delve into the details and calculate every last number if you're kind of alert to what's going on generally in the graph. All right, let's look at the second question. If the total value of all credit card transactions in 2009 was 10% more than the total value of all credit card transactions in 2006, then the average, or arithmetic mean, value of credit card transactions increased by blank percent from 2006 to 2009. Okay, a lot going on there. So let's see if I can get some variables to define the quantities that they're presenting me, the quantities that they're asking for. Now I notice they want the average value, well, the increase in percent of the average value of the credit card transactions. So is that what I have on the graph? Well, I want to remind myself, no, I'm told number of transactions in millions, not the average value of the transactions. So let's get some variables for that. I'll say the average value in 2009, I'll call that A9. So just to remind myself, that's the average value of the CC transactions in 2009. And I'll do the same thing for 2006, average value for the credit card transactions in 2006. Okay, and then what do they want to know again? Well, it's the increase in percent. So, okay, I'm thinking about my change in percent formulas. I have my good old new minus old over old. And that could in theory work in this context, I suppose. So I could say, if I could find A9 minus A6 and divide that by A6, that could work. But that's not the only way to get at percent change. And, that's a formula that it can be fine if I have actual numbers that I'm plugging in that are fairly simple. But it could also get ugly if I have some algebra to deal with. So I would also be able to figure out the increase in percent if I could just find the simple ratio. And I could extrapolate from that the change in percent. So I don't want to get too rigid. I want to keep in mind that both of these could lead me to finding percent change. And just a quick review of what I'm talking about, why both of these could tell me the percent change between two numbers. Let's say I'm going from 8 to 10. Okay, so if I use that first formula, I get 0.25. And that tells me, okay, that's a 25% increase from 8 to 10. But I could also say, well, 10 divided by 8 is 1.25. My new value is 10, my old value is 8. And I could say, well, if the new value is 1.25 times the old value, it must be 25% greater. And, potentially, again, that could be simpler if we have a lot of algebra to deal with. Okay, so what else am I told in this question? Well, they start with talking about the total value of the credit card transactions in 2009-2006 and how they relate. Now, again, I don't actually know the total value because this graph is just telling me the number of transactions. So I guess I'll need some variables for that. So I'll say the total value of the credit card transactions in 2009 and the total value of the credit card transactions in 2006. I'll call those T9 and T6. Okay, and then what's the relationship? Well, the total value in 2009 equals 10% greater. Okay, well, if I multiply something by 11 over 10, that'll increase it by 10%. So I could say, here's my translation of that statement. The total value of the credit card transactions in 2009 was 10% greater than those in 2006. Okay, so I know a relation between T9 and T6. Maybe that will help me figure out the relation between A9 and A6. What other information do I know? Well, keep in mind, I know the total number of transactions. So the number of transactions, the number in 2009, consult the chart, that was 20 million. And the number in 2006, that was 22. Okay, so how can I relate all of this information to somehow get at one of these here, A9 over A6 or something like that, which would allow me to get the percent change? Well, what's my formula for average? Well, keep in mind, just the general average mean formula is the average is equal to the sum over like the number of numbers, you could say, right? I sum up all the numbers, I get their total value. I divide by the number of numbers, and that gives me the average. Well, notice these could be related in that way. I could say, well, the average in 2009, A9, is equal to the sum of all the values of credit card transactions in 2009. Well, that's what T9 is. That's one of my variables. Over the total number of transactions. So total value of the transactions over total number of the transactions. And in 2009, that was 20. Okay, I could do the same thing for the average value of the credit card transactions in 2006. It's the total value of the credit card transactions in 2006. I've got a variable for that over 22, which is the number of transactions. Again, I got that number off the graph. Okay, so I have this equation here, and I've got these two equations here. Ultimately, I'd like to have some relation between A9 and A6. This gives me a relation between T9 and T6. And if I use these equations strategically, I can plug in for T9 and T6 so that I get this equation in terms of A9 and A6. Okay, so I took a step back, I looked at all the equations I have, think about where I want to get. Aha, I could use substitution to isolate the variables that I'm most interested in. Okay, so I can see from this equation, T9 is A9 times 20. So I'm going to rewrite this equation with T9 is just A9 times 20 equals 11 over 10. Okay, T6, well, I'll multiply the 22 over there. So that's equal to A6 times 22. Okay, now I think I'm in good shape. Because if I manipulate this, I should be able to get A9 over A6. Okay, so I'll divide both sides by A6. I'll divide both sides by 20. So I get A9 over A6 is equal to 11 over 10 times 22 over 20. Okay, what's 22 over 20? Simplify that, that's just 11 over 10. So what's 11 over 10 times 11 over 10? That's 121 over 10, or 1.21. Okay, great. So A9 over A6 is 1.21. So if A9 is, 1.21 times greater than A6, it must be 21% greater. Okay, so there we go. That's what I was looking for. What's the percent increase in the total value of credit card transactions from 2006 to 2009? It was 21%. Okay, so that leads me to the correct answer on this one, question number 2 of C. I'll just put that up here. Okay, so what's the takeaway for that question? Well, notice in general, these graphical interpretation questions, a lot of times the quant isn't all that heavy, right? It just kind of hinges on if I'm carefully interpreting a little made-up word there, interpreting the graphs, reading the axes correctly and all that stuff, then the quant really isn't the most demanding part. On the other hand, you will occasionally hit a question like this, where there actually is some subtle algebra to go through, but as long as you're defining your variables, keeping track of, what are your different paths, what are your different tools, you can work your way to the answer. Okay, great. So that wraps up our video on key quant skills for graphical interpretation. All right. Well, thanks so much for watching. I hope you enjoyed the video. And just to review, some of the key quant skills you're going to want for graphical interpretation include knowing when you can estimate and eyeball in a question, avoid getting lost in the details and wasting time on that kind of thing, and when actually you do need to go in and do some calculations and get a specific quantity. So basically, learning to recognize the difference between those two situations. You also want to be comfortable with correlation, knowing what's positive correlation, what's negative correlation. But aside from that, not overthinking this kind of question. They're not asking for any kind of elaborate calculations. You just need to be able to spot a reasonable trend in the data. Now, for rates of change, ask yourself, can I look at a graph and understand what it means to find an average rate of change between 2 points? Or to understand what does it mean for a rate of change itself to increase, or stay the same, or to decrease? And of course, although most of the quant skills you're asked for on graphical interpretation aren't going to be all that heavy, you will now and then encounter a question like the one we just did, where it gets into some fairly lengthy and complicated algebra. And of course, bigger picture on graphical interpretation, it's all about understand the graph, understand the axes, make sure you're getting the big picture, make sure you understand exactly what they're asking for so you can avoid careless errors. And if you're doing all that, you should be in good shape. All right, well, thanks for sticking around, and I'll see you next time.